Welcome to Wonderverse, where we explore the strangest, most beautiful, and surprising mysteries of the universe. Today, we're answering a question that's crossed everyone's mind at least once. Why do stars twinkle? Have you ever looked up at the night sky and wondered why stars seem to blink or flicker? Sometimes they shine brightly, other times they dim slightly, even change color for a second. So, what exactly is going on? Let's start with what we actually see. On a clear night, the stars appear to twinkle. Their brightness flickers, and they sometimes shimmer with changing hues. But if you look closely at planets like Venus or Jupiter, they don't seem to twinkle the same way. Why the difference? The reason lies in the distance and nature of the light. Stars are incredibly far away, so far that to our eyes, they appear as tiny points of light. Planets, on the other hand, are much closer, and even though they still look small, they appear as tiny disks in the sky, not just pinpoints. This is one of the key reasons stars twinkle more than planets. When a star emits light, that light travels through the vast emptiness of space, what we call a vacuum, for hundreds, thousands, even millions of years. Nothing disturbs it during that journey. It travels in a straight, perfect path until it hits Earth's atmosphere. And that's when everything changes. Our atmosphere is not a uniform layer. It's made up of moving air, different temperatures, different pressures, and varying densities, all constantly shifting due to heat from the Earth, wind patterns, and moisture. It's similar to looking at a straw inside a glass of water. When you look from the side, the straw appears bent or broken. That's because of refraction, the bending of light. The same thing happens with starlight. As light from a star enters Earth's atmosphere, it gets bent by these moving layers of air. This bending, or refraction, happens repeatedly and randomly as the air moves. Sometimes the light bends slightly to the left, sometimes to the right, or up and down. And by the time it reaches your eyes, it looks like the star is shimmering, twinkling, or even changing color. This whole process is called astronomical scintillation. It's the scientific term for why stars twinkle. The intensity of twinkling changes depending on many factors. If the air is very unstable, meaning there's a lot of turbulence, wind, or temperature differences, the stars twinkle more. On calm, quiet nights, they twinkle less. Planets don't twinkle as much because, as mentioned earlier, they're larger in appearance. The light coming from different parts of the planet averages out the atmospheric distortion, so they appear steadier. But a star, which is just a pinpoint of light, is affected more dramatically by every little change in the atmosphere. For astronomers, this twinkling isn't just a beautiful phenomenon, it's actually a problem. The constant flickering can blur telescope images, making it difficult to get clear, sharp views of distant stars. To solve this issue, scientists use a technology called adaptive optics. These systems detect the distortion caused by the atmosphere and adjust mirrors in real time to cancel out the effect, kind of like noise-canceling headphones, but for light. Even better, telescopes like the Hubble Space Telescope are placed in outer space, far above the atmosphere, where there's no distortion at all, and no twinkling. But twinkling isn't only about science, it's inspired culture, poetry, and art for centuries. Think of the classic nursery rhyme, "Twinkle, twinkle, little star." It may seem like a simple childhood song, but behind it is a deep scientific phenomenon that's fascinated humans for generations. Many ancient cultures believed twinkling stars were messages from the heavens or signs from the gods. Even today, there's something magical and emotional about seeing stars twinkle in a dark sky. It reminds us that the universe is alive, moving, and full of wonder. Your location on Earth also affects how much twinkling you see. At sea level, where the atmosphere is thicker and often more humid, twinkling is more intense. But if you go up to high-altitude locations, like mountaintops in Hawaii or Chile, the air is thinner and more stable, so stars appear much steadier. This is why the world's most advanced observatories are built on mountains, for clearer, less distorted views of the cosmos. So, can we predict when stars will twinkle more or less? Yes, just like we predict the weather. Astronomers use tools like DIM, differential image motion monitor, and atmospheric models to measure the quality of the night sky, especially something called seeing, which tells them how stable the atmosphere is. Poor seeing means more twinkling. Good seeing means clearer skies. So next time you're planning a stargazing night, check the seeing forecast the way you'd check the weather. You might catch a night when the stars are crystal clear. At its core, the twinkling of stars is a beautiful blend of physics and perception. It's a result of an incredible journey. A photon of light born in a nuclear reaction inside a star, traveling through the universe for millions of years, only to be nudged and bent by our moving sky in its final moment before reaching your eyes. It's humbling, really. That tiny sparkle in the sky is the end result of a cosmic voyage, one that connects us to stars beyond imagination. So, the next time you're under a starry night and you see that gentle shimmer, remember, it's not just pretty, it's light shaped by the Earth itself, and a sign that you're looking up at something unimaginably far away. That was another journey through the cosmos with Wonderverse, where we uncover the science behind the beauty of the universe. If you enjoyed learning something new today, stay tuned for our next adventure. And always remember, every twinkle in the sky carries a story waiting to be told. If you enjoyed this journey through Nova Nerd, don't forget to subscribe and hit the bell so you never miss the next cosmic mystery.